Okay, so this is section 4.4. It's dealing with solving trig equations. Sorry, I can't talk. Part 1, I've just divided into 2 parts because one part's more with solving equations, and the second part is still with solving trig functions and equations, but with doing a little bit more steps to it, I guess. So this is kind of the initial part, and then we'll build on it. So in our last couple sections, we've used the special triangles in order to help us find exact values. This is still going to be using those special triangles to help solve. So we have our 45, 45, 90 triangle, and of course, this is the same as 45 is the same as pi over 4. Our ratios were 1, 1, and square root 2 when we weren't working with a unit circle. And in our 30, 60, 90 triangles, this was 60, which is the same as pi over 3, 30 degrees, which is pi over 6, and of course our 90. And our ratios for this were 2, 1, and square root 3. So that's a good thing. By now you should pretty much have those memorized, or you should try to memorize them. They don't, I believe they don't give you those on your departmental exam, so you need to put them into your memory bank. So example number 1, it says that sine x is equal to 1 over square root 2. So what we want to do is we want to find out what possible value could be for x. Okay? X is the same as theta, they're just giving it a variable now instead of using the theta symbol. So if x is equal to 1 over square root 2, the first thing you do is you take a look and you decide, okay, which of my special triangles has that square root 2 value in it. So of course this is our 45, 45, 90 triangle. So I know that that's the one I'm going to be dealing with. So I have sine is equal to opposite over hypotenuse, so those are the ratios that I'm dealing with. So now I'm going to use that to draw my triangle. So sine, it's a positive value, so I need my cast rule as well. So I know that sine is positive in here and here, all in sine. So if I draw this in, these are my 2 possible solutions. My opposite, this is my angle x, my opposite is a 1, my hypotenuse is a square root 2, so it works the same for there. So because I know that it's using 1 and square root 2, I know that it's a 45, so I know that my x is equal to 45 degrees, or pi over 4. But it's also, so that takes care of this angle in here, but I also need this angle here. So because that's in quadrant 2, I'm going to do my 180, ignore that, 180 minus my 45. So my other angle is 135 degrees. If I need to answer this in radians, so I have 2x is equal to 45, or 135. If I need to do this in radians, I know it's pi over 4. And then it would be pi minus pi over 4, so that would be 3 pi over 4. So what you need to do is you need to draw these in here, figure out which triangle you're using, if it's a 30, 60, 90, or if it's the unit circle, or if it's a 45, 45, 90. So secant x is equal to negative 2. So secant x, of course, is a reciprocal function, and that is the reciprocal of cos. So this really means cos of x would equal negative 1 over 2. And I know that cos is equal to, if I think of, you can use opposite or hypotenuse, or if you think of your Sir Kicks or Ticks, it's x over r. So I draw my, I kind of got a little big there. cosine is negative if I'm thinking of my cast rule. Cosine is negative in quadrant 2 and quadrant 3. So I know my triangle is going to be here, and it's going to be, oops, sorry, there. They should be both exactly the same triangle. So my ratios are x is equal to -1, and my r is equal to 2. And I know, because this is negative, my r, my radius, or my hypotenuse is never a negative value, so I know that that negative has to go with my x. So this value here is -1. Here it's a 2. So when you take a look at that, you know that in order to have my x equal to -1 and my r equal to -2, these are the adjacent and the hypotenuse for so the adjacent side having a value of -1 would be here. The hypotenuse having a value of 2. Here's the -1. Here would be the 2. So I know I'm working with 60 degrees over pi over 3. Get a sneeze. Excuse me. So I know my reference angle is equal to 60 degrees. So that's going to take care of the reference angle. But I have two angles that I'm looking for. I'm looking for this angle to get me to there, and then I'm also looking for this angle. So this angle in quadrant 2 would be 180 minus 60 degrees, so it would be 120 degrees. In quadrant 3, I'm going past that 180, so it's going to be 180 plus my reference angle, so it's 240 degrees. So my x in this case is equal to 120 or 240 degrees. I don't worry about the reference angle there because the reference angle, my one angle wasn't in quadrant 1, so I don't use that 60 value. I only use it for calculation purposes. If I'm thinking about this in radians, this is the same as pi over 3. So my 1 would be, not 180, it would be pi minus pi over 3, so that's 2 pi over 3, or it's going to be pi plus pi over 3, so that'll be 4 pi over 3. So my x could equal, I'm getting too big here, 2 pi over 3, or 4 pi over 3. I'm going to have to make the next one a little squishier. So tangent is equal to, what's that tick? So it's either y over x or the opposite over adjacent. And it's kind of a good idea to keep both of those in mind. So tangent to have a value of 1 means that I'm looking at which of my triangles here are going to have a ratio of 1. I know it's not going to be the unit circle, because if I think about my unit circle like this and my values, I'm never going to have a value. I won't be able to have a tangent of 1 because my x and y's that I'm working with always are just 1s and 0s. So it's either going to be 0 or undefined. Okay, so I know then the only other option I have for a tangent is to use that 45, 45, 90. So tangent is positive in quadrant 1 here, or it's going to be here. Remember, your right angle is always with the x-axis base. So if it's here, then I know that 45 degrees is going to give me my ratio. So here I would have a 1 and a 1 as my opposite and adjacent. This one I would have a -1 and a -1. And if I put that in my ratio, -1 divided by -1 is just a positive 1. So I know that works. So now I have to find my quadrant 3 one. So I'm looking for this one. So I know that one is going to be 180 plus my reference of 45, so it's 225 degrees. So my two angles would be 45 degrees and 225 degrees. If I'm looking at this in radians, 45 degrees is pi over 4. So I have pi over 4 will be 1, and then pi plus pi over 4. So that's 5 pi over 4. So x would be pi over 4, comma, 5 pi over 4. Okay, but not all equations that you get are going to be in tangent equals, cos equals, sine equals. Sometimes you're going to have to do a little bit of order of operations to get them into that statement. So 2 cos x minus 1 is equal to 0. Well, I need to have this. That's your variable that you want all on its own. So the first thing I'm going to do is add 1. So I have 2 cos x is equal to 1, and then I'm going to divide by 2. Oh, divide by 2. So I have cos x is equal to 1/2. So for cos x to equal 1/2, if I look at my triangles, the only one that have the 1 and the 2 is my 30, 60, 90. Cos is adjacent over hypotenuse. So to have an adjacent side of 1 and a hypotenuse of 2 means that my angle that I'm looking at is 60 degrees. So that's going to give me one of my angles. I have to see if this is true for the other one. So my restrictions are between negative pi and pi. So negative pi means I'm going in this direction, and pi means I'm going, in this direction. So I'm basically, it has to be in the top or it has to be in the bottom. It can't be going all the way around. It's going to be my restriction. So if x is equal to 60, then I take a look. Okay, cos is positive in quadrant 1 and quadrant 4. So I know it's going to be either here or it's going to be here. So when I'm doing my calculation, I know, well, right off the bat, this one here, that is 60 degrees. So that is one of my values. My other one then, and this is where this negative pi comes into play, because I'm not, and I'm just going to draw it in, I'm not looking for this angle, because that would be more than a positive pi. So I'm actually just looking for this angle, because I can only go to pi. I have to start here and go this way, or start here and go that way. So then my other reference angle would be negative 60 degrees. So if I did that in radians, it would be pi over 3, and you could just put plus or minus pi over 3. Okay, the next one, square root 3 secant x plus 2. So again, I have to solve. I want my secant x all by itself. So I subtract my 2. So I have square root 3 secant x is equal to negative 2. Divide by square root 3. So I have secant of x is equal to negative 2 over square root 3. Secant is a reciprocal function, so I have to do my flip. So I have cos of x is equal to square root 3 over 2. Now I have to keep in mind, okay, where am I going to put that negative sign? Cos is adjacent over hypotenuse. I know my hypotenuse can't be negative, so my negative will go with that square root 3. So I take a look at the 30, 60, 90 triangle. And I have to decide, okay, which one has the adjacent side of square root 3 and a hypotenuse of 2. So that means it's going to be that 30 degrees. And because actually this one I don't even need to do degrees, because my restrictions were in pi, I should just be using pi. So x is equal to pi over 6. cos is negative. So cos is negative in quadrant 2 and in quadrant 3. So I know my reference angles in both of these are going to be that pi over 6. So my reference angle is pi over 6 in both of these. So this one's going between negative pi and pi, so the first one I'm going to look for is this angle. So that'll take care of that positive turn. So in quadrant 2, I have pi minus pi over 6, so that's a 5 pi over 6. In quadrant 3, though, because I've got that negative pi restriction, means I'm going to find the clockwise, so I'm going to here. So in quadrant 3, it's going to be quadrant 3. It's my negative pi, because I'm going in the negative direction, and then my reference angle of pi over 6, so it equals negative pi over 6. So those would be my two answers, positive pi over 6 and negative pi over 6. Okay, next example. 5 sine x minus 2 is equal to negative 7. So I add my 2. So I have 5 sine x is equal to negative 5. Divide by 5. Sine of x is equal to negative 1. Now sine is opposite over hypotenuse. I don't have a unit circle where I have a hypotenuse, because this is, if I think of this as opposite over hypotenuse, I don't have a unit circle, or sorry, a special triangle where I have a negative 1 side and a negative and a 1 hypotenuse. So that there tells me that I have to use the unit circle. So I'm just going to put a little star here. So neither special triangle okay? So neither special triangle has a hypotenuse that is equal to 1, and I put a negative 1, it doesn't matter, just 1 in general, so positive or negative. So that means that I can't use either one of the triangles, but my unit circle could have a value of 1. So if I think about this, if I do my unit circle, remember your sine is your y value, and cos is your x value. So if I look at my values here, I have a 0. Sorry, that should be 1 and 0. Okay, that's not a negative 1. My cos is the 1. Here is 0 and 1. So my sine is equal to 1, but it's not a negative 1. This one had the value of negative 1, 0. Well, that negative 1 is my cos value. This one is 0, negative 1. So y, in this case, my value would be x is equal to 0. And just y is equal to negative 1. But this one, the reason why we put it at, or we put both of them, is because we wanted to know where sine x is equal to negative 1. So it's right there. So our x value would have been 0. So that means for my answer on this one, and because it's between pi and negative pi, we're looking at this angle here. If I went all the way around, I'd be going past pi, so I can't, this one is wrong. So I have to use this one here. So that means at this point here, to go from, in a clockwise turn from here to here, would be pi over 2. Sorry, negative pi over 2, because it's a negative turn. Okay, next one. 2 square root 3 tan x plus 1 is equal to 3. So I start the same thing, subtract 2 square root 3 tan x is equal to 2, divide by 2, square root 3 tan x is equal to 1, divide by square root 3, divide by square root 3. So tangent is equal to opposite over adjacent. So I take a look and see, okay, which of my special triangles uses the square root 3? That's the 30, 60, 90. And then I check and see which is the one that has the opposite side equal to 1 and a square root 3 equal, or sorry, square root 3 equal to the adjacent side. So that is my pi over 6. So pi over 6 then is my reference angle. It's a positive value. Tangent is positive here in quadrant 1, and it's positive here in quadrant 3. So that means my one angle is going to be pi over 6. The other angle, though, going this way, is going to be negative pi plus my pi over 6. So it's going to be negative 5 pi over 6. So my two answers would be x is equal to pi over 6 or negative 5 pi over 6. Okay, finding general solutions. It says previously we solved the equation 2 cos x minus 1 is equal to 0. What about all the possible values? How would you list the general solution to this equation? So we put the restriction in here. But what happens if it says list all the possible values? How would you find that answer? So our solution to that one, that was the first one on the second set of examples, was x is equal to pi over 3 or negative pi over 3. So this is the same thing as we were looking at before when we were looking at coterminal angles. It's the same type of idea. It's how many more times you go around, you just add that 2 pi to it. So if I just did one rotation, I'm just going to, whoops, write this. If I went one rotation, that's going to be a 2 pi. So I would just be adding 2 pi to that value. So that would mean I would have my new value, or my next coterminal angle, would be at 7 pi plus 3. Because I would be adding on 2 full pi's, so that's 6 pi over 3 plus 1. Means that I'm going to add on 6 more to my initial one. I could go one more rotation, so I'm adding on another 6 pi plus 3. So that would give me 13 pi. Oops. That should be a 13, not a B. Okay, what if I went, still going in a positive rotation, if I added 2 pi onto this one, I would have negative pi over 3 plus 6 pi over 3, so that's a 5 pi over 3. If I added another 2 pi onto that, that's going to be another 6 pi onto there, so that's going to be 11 pi over 3. So what I've done here is I've taken my principal angle, and I have added 2 pi and then rotation around there. And remember, n is an integer. For this one down here, I did the same thing. I went negative n pi, or negative pi over 3 plus 2 pi n, and n is also an integer. So if it asks you to find more angles, you don't have that restriction in there, then you're just going to add 2 pi and then however many rotations you want. I could have went 6 more if I chose to. Okay, so let's solve the next one. This is on the interval between negative 2 pi and 0. So if I think about it here, I'm doing this and then 0. And then it says, and then find the general solution. So there's 2 parts. So tangent theta, I'm just going to move this over. Tangent theta is equal to square root 3. So again, I take a look and see, okay, which ones use square root 3 as my, that's opposite over adjacent, so that would be the same as square root 3 over 1. So that is going to be my 30, 60, 90 triangle with 60 degrees as the reference angle. So theta is equal to pi over 3. And again, I'm using pi because, or I'm using radians because it's in my restrictions. So tangent is positive here and positive here. I know I'm using a reference angle of pi over 3, so because pi over 3 is greater than 0, I can't go in a counterclockwise, so that means I'm going to have to go this way and find out what that angle is. So that means I'm taking all the way around would be, so for my red one, that's a negative 2 pi, and I am taking off that little hunk in there, and because it's in a negative, I do the opposite sign, I add to it. So that means I have 6 pi over 3 plus pi over 3, so it's a negative 5 pi over 3. So that took care of my one angle. My second angle then, again, I can't go all the way around clockwise because that is greater than my 0, but I can go in this direction. So it's this angle that I'm looking at. So that theta is going to be, I'm going to negative pi direction, and my reference angle is still the same, it's that pi over 3, so I add pi over 3 to that to get negative 3 pi over 3 plus pi over 3, so that's negative 2 pi over 3. So this is called my principal angle. My general solution then is just going to be, for my first one, I would have to use a value of negative 5 pi over 3, and then I would add 2n to it. For my second angle, I would be using negative 2 pi over 3 and adding 2 pi n to it. And what you may have noticed is whenever we're dealing with the tangent and we're dealing with either they're being positive or negative, they are always, the two angles that we're dealing with are always making, I'll just do this in green, they're always making a straight line. Okay, between the two reference angles, when you plot them in there, you should have a straight line. Okay, for cosecant theta is undefined. So undefined means you would have had to divide by 0. So then I have to take a look at, okay, which ones would I have a 0 in them? Which of my special triangles or whatever would have them? Well, the triangles don't, but my unit circle does. Cosecant is the same as sine. So if this is cosecant is undefined, that means that my sine theta would have to be 0 over 1. This one would have been 1 over 0 to give me undefined. This one is sine is equal to 0 over 1. So that means my y has to be 0 and my r has to be 1. So if I draw my unit circle, my y is at 0 right here and right here. So this was 1, 0. This was 0, 1. So right here at 1, 0, that means my angle would be 0 degrees. If I'm going in the other direction, if I want to go in my clockwise direction, I would go from here all the way back to there. So in that case, theta is equal to negative 2 pi. Oh, but my one restriction said it has to be less than that. So I can't use that one. That means it's equal to. So I throw that one out. So my other one that I'm looking at then is the one that's using 0 and 1. So I can't go in a counterclockwise because that's going to be greater than 0, and it has to be less than 0. So I'm going in this direction, which means I'm just going to that point there, which meant that I went a negative pi turn. So my two general solutions would be 0 plus 2 pi n, and for the other one it would be negative pi plus 2 pi n. And for this one, because I'm dealing with 0 and 180, like every time I do, if I went from here to here, 180, I would have one. If I went back to here, I would have one. If I went around here. So I could actually just be adding a pi. So that's a special case where you wouldn't have to say 2 pi n. You could just be a pi n. Okay. Next one. So it says, what about values which are not on the special triangles? Okay, so we are going to come into situations where you don't have a special triangle that's going to work. You're not going to have that square root 3, 1, and 2, or 1, 1, square root 2. So that means you have to do a little bit of calculating, and this actually you would have done in your Foundations 20, if you remember. So this is in radians, so you have to make sure your calculator is in radians when you're doing this. So sine of theta is equal to 0.175. So that means I need to get rid of my sine, which basically is, I'm doing this. I'm dividing through by sine. But I can't write divide by sine, so what I'm doing is sine inverse. So you remember the other day when we were on your calculators, when we started with reciprocal functions, you said you can't use that second function sine to get cosecant, because that's an inverse function and we were dealing with reciprocal functions. So now you can use that. On your calculator you would hit second function sine 0.75. So your reference angle that we're dealing with here is 0.848. So sine is positive. Sine is positive in quadrant 1 and in quadrant 2. So these would be my two reference angles. So my first one, my theta is just going to be 0.848. My second one, because it's in this quadrant, theta is going to equal to, I'm going pi minus 0.848, and I really should have done that to 4 decimal places. I don't know why I did it to 3, but it's not a big deal. So my answer then is theta is equal to, and it'll be an approximate 2.294. I rounded that. Okay, secant theta is equal to 7. Well, secant is a reciprocal function. Secant is the reciprocal of cos. So this is 7 over 1, so that means my cos of theta would be 1 over 7. So to find out what theta is equal to, I put theta is equal to cos inverse. And make sure when you're doing this on your calculator, you do 1 divided by 7 in bracket. Otherwise, it'll do inverse cos of 1, and then divide your answer by 7. So here I found out theta is equal to 1.427. So again, cosine is positive here, and it's positive here. So in this angle, that is that 1.427. In this case, it's this angle here, so it's going to be 2 pi minus 1.427. So when you do that on your calculator, it's equal to 4.856. Okay, sometimes in your questions there, instead of giving you intervals of between 3 is less than equal to x is less than equal to 7, they're just going to use brackets. And there's two different kinds. There's your parentheses type bracket and then your square bracket, and they each mean something different. This one is going to have number, comma number, which means it's going to be between that number or that number, and these are open intervals. So that means it's going to be exclusive, or it will exclude values. So this would be similar to using those. The square bracket is called the closed interval. Those ones are inclusive, which means they're going to include values. So that's the equivalent of using the greater than equal to, less than equal to signs. So the next example says, how would you interpret parentheses 3, comma, 7 square bracket? So that means this one, the first one, means it would be, your interval would be from 3 to 7, not including 3, but including 7. The second one, which has the square bracket and then the round bracket, would be the interval from 2 to 5, including 2, excluding, or not including 5. So it says, how would you rewrite these, or rewrite this as actual inequalities? The first one would be, we're going between 3 and 7. Not including 3 means it's going to be like that. Including 7 means it's going to have the equal to sign. The second one would be, you have your 2, and your variable, and your 5. It's including 2, so it needs the equal to sign. Excluding 5, so it's just that without the equal to sign. Okay, so your questions are on page 211, 1, 2, 4, 5, and 6. You can work on those ones in class.